Hi everyone and welcome. In this video, I'm going to walk you through the pRecipe package in R, a powerful toolkit for accessing, exploring, and analyzing global precipitation data sets. If you work in hydrology, climate science, environmental modeling, or simply need reliable rainfall data for research, this package can make your workflow easier, more consistent, and fully reproducible. Before installing pRecipe, there are a few system libraries you'll want to have installed. These include Project, GDAL, and netcdf. These libraries handle mapping projections, geospatial data formats, and large scientific data files, especially the netcdf format that most precipitation datasets use. If you install our geospatial packages regularly, you may already have them. If not, follow the installation instructions for your operating system, and then you'll be ready to install pRecipe. One of the strengths of pRecipe is that it includes a database of 27 homogenized global precipitation datasets. These include 6 gauge-based products, 8 satellite products, 8 reanalysis datasets, and 5 outputs from hydrological models. The important part is that pRecipe stores all of these datasets using a consistent structure. Every dataset is converted to the same variable name, TP, for total precipitation, the same units, millimeters, the same spatial resolution, 0.25 degrees, and a consistent file naming convention that encodes the dataset, version, coverage, time span, resolution, and time step. That means if you learn how to work with just one dataset in pRecipe, you already know how to work with all 27. Once your system dependencies are in place, installing pRecipe is simple. In your R console, type install.packages pRecipe. In a fresh installation of R, it might take longer as all the dependencies will be installed prior to installing pRecipe. If there is any package with unsuccessful installation, the error will be shown in the console. If needed, troubleshoot the errors for those dependencies for pRecipe to be installed smoothly. And once it's installed, load it by running library pRecipe. That's all there is to it. You're now ready to download, explore, and analyze precipitation datasets. Let's look at the typical initial workflow you'll use when working with pRecipe. The process usually includes 3 simple steps. Step 1. Download datasets. With pRecipe, you can download many popular precipitation products directly from R. The package handles URLs, file names, and storage automatically. Let's download GPM iMerge final VO7 data in the console run. Download_data dataset equals GPM emerge. The download time will depend on the dataset you choose and your internet. I will skip to the completed download to continue with this demo. After downloading, you can inspect the dataset structure, time span, spatial coverage, and other attributes. First, load the downloaded dataset by running pre_data raster colon brick GPM RMEV7_TP MM global _1999801 202406 025 monthly.nc. Now to inspect the metadata of our file we run, infonc_prec_data. Here we will see the data's resolution, spatial extent, KR's projection, and temporal coverage, among others. Moving into step 3, visualize. pRecipe integrates smoothly with ggplot2 and comes with built-in visualization functions. You can create time series plots, density plots, box plots, heat maps, seasonal climatology plots, and even tailor diagrams for dataset comparison. Here are some examples. To visualize a time series plot of your data, run plot _line_prec_data. This plot may take a minute because first it needs to compute the global average before plotting a single time series. To observe a map of your data, run plot_map_preq_data. Note that by default the first layer will be plotted, but you are free to specify a different layer for a date of your interest. Lastly, for today's demo, we will have a look into the seasonality of our data by running plot_boxprec_data. These steps together create a clean, reproducible workflow that lets you download raw precipitation data, visualize it, and start to analyze it, all from within a single R script. If you use pRecipe in your research or publications, the authors ask that you cite the package and acknowledge the data sources. This helps support continued development and ensures transparency in scientific work. The package's main references Vargas Godoy, MR, and Marcanis, Y 2023. pRecipe, a global precipitation climatology toolbox and database. Citing software and data is an important part of reproducible science, and pRecipe makes it easy to keep track of the data you use.